Alrighty, hello my people, I hope we're doing well. I decided to call an audible and I'm going to go ahead and prove Herons at the beginning of this video and then get to a couple of examples towards the end. I just think that this is the place to do it, there's enough time. Now, remember that a lot of this has to do with your ability to drop this altitude and create right triangles. Now, the proof of Heron's area formula is no exception, okay? What we have here is we have h. Over here, let's again call this x, and over here, let's again call this b minus x, okay? Now, let's go ahead and create the Pythagorean theorem for both of those triangles, for both of those right triangles, okay? The left-hand right triangle is x squared plus h squared is equal to c squared. The right-hand triangle is b minus x squared plus h squared is equal to a squared. Now, we can solve both of these for h squared, and we get c squared minus x squared on the left-hand side, and h squared over here is a squared minus b minus x squared. Now you need to be careful about this negative when you FOIL this out, because when you FOIL it out, then the negative gets distributed to all three terms. But I am going to combine, I'm going to set both of those equal to each other. Actually, let's go ahead and do this first. So you get a squared minus b squared minus 2xb plus x squared. And then when I set this, I set these two equal to each other, right? Since they're both equal to h squared, they're equal to each other. I'm going to get c squared minus x squared is equal to a squared minus b squared plus 2bx minus x squared. Okay, well that's helpful because I tell you what, this and this cancel out. All right, let's go ahead and start at the top of the next page. And let's rewrite what we have, or let's, after simplifying. We recognize the fact that we have c squared is equal to a squared minus b squared plus 2bx. What I'm going to do is I'm going to pull the a squared over to the left-hand side, and I'll go ahead and reorder this right-hand side so that I don't have a leading coefficient that's negative. Now, what I also want to do is now I want to solve for 2bx, and if I do that, what happens is I get 2bx is equal to b squared plus c squared minus a squared. And then let's solve for x. Remember that what we want in the end is we want a formula that is based on everything that is inside, that is part of the triangle itself, right? So ultimately we don't want a formula with x in it. We want x to sort of disappear. We want h to disappear, and we want a formula for the area that is just in terms of a, b, and c, especially for Heron's area formula. But basically, we want a formula that deals with the values that are given to us rather than ones that we have to derive, because we have to derive, the formula is not as good, right? Now, what we're going to do is we're going to square both sides. Okay. Now, you need to recognize that because h squared plus x squared is equal to c squared, that was on the previous page, okay, we can get the fact that h squared is equal to c squared minus x squared. Okay, well here's the thing. I have x squared, it's this whole big thing. So I can rewrite h squared as c squared minus that whole big thing, b squared plus c squared minus a squared, all of that over 2b squared. Now, as monstrous as that looks, that is the difference of two squares. Okay? And I'm going to go ahead and break it apart as such. So I get c, so this is my first square, and this whole thing is my second square. So it's c plus b squared plus c squared minus a squared all over 2b, and c minus b squared plus c squared minus a squared, all of that over 2b. Now, what I'm going to do from here is I'm going to get a common denominator within those brackets. So I'm going to multiply c by 2b over 2b in both of these. Now, the thing I need to be careful about is this negative. This negative, of course, gets distributed over that trinomial because that numerator is functionally, parentheses. But what I'm going to get here is h squared is equal to 2bc plus b squared plus c squared minus a squared, all of that over 2b. And then when I get the common denominator and distribute that negative in the second one, I'm going to get 2bc minus b squared minus c squared plus a squared. Notice that all three terms in that trinomial, these three terms, change sign. Now from here, we're gonna basically recognize the fact that area is equal to 1/2 base times height. And it just happens to be b as well. But now, if that's the case, then 2 times the, and I shouldn't put a because that's the same as that. Let's call it area. Okay, 2 times the area is equal to bh. And if I square both sides, I get 4 times the area squared is equal to b squared, h squared. And the last thing I'm going to do is, let's say that 16, if I multiply both sides by 4, is equal to 4b squared h squared. And if you're thinking to yourself, why in the world is that important? I need you to look at those two denominators. I'm going to multiply both sides by 2b twice, okay? So this is more like sort of an interlude that allows us to do this next step and shows us that 4b squared h squared, which is equal to 2bc plus b squared plus c squared minus a squared, and 2bc minus b squared minus c squared plus a squared, that is equal to 16 times the area squared. Now, basically, all this has just been clever substitution, and none of this has been trig related, right? Now, what I'm going to do is, you need to recognize the fact that basically this is 2bc. That is a perfect square trinomial. Okay? And basically what's going to happen is this is also a perfect square trinomial if we sort of rearrange the signs in a way. These are going to combine also into a perfect square trinomial. And so what happens here is this winds up being b plus c squared minus a squared, and this over here winds up being a squared, because a squared is positive, and then if I factor a negative out of all three of those, what I'm going to get is b minus c squared. And now I have two factors that are both the difference of two squares. And what's going to happen here is I'm going to get b plus c plus a, b plus c minus a, a plus b minus c, and then a minus b minus c, but you have to distribute the minus, and it winds up being that. Now, remember that when we're dealing with this, we are defining the semi-perimeter as S. S is half of the perimeter. So if that's the case, right, if S is equal to a plus b plus c over 2, then 2s is equal to a plus b plus c. Okay, well that makes easy work out of that one. Now in this one, if I add a and subtract a, right, and let me just go ahead and, if I take b plus c minus a, and then I add a and subtract a, and I can do that because I haven't changed the value, what I get is a plus b plus c minus 2a, or 2s minus 2a, right? Because this is 2s. And so this one is 2s minus 2a. This one, something similar happens, right? I get a plus b minus c, but then I'm going to add c and subtract c in order to change the form of this, and I get a plus b plus c minus 2c, or 2s minus 2c. So I get 2s minus 2c. This one is going to go exactly the same way, but it's going to be minus 2b. They all have a common factor of 2 out there. Isn't that interesting? Well, let's pull out all those 2's, and that's 4 2's. So that's 16 times s minus a times s minus b. I'm just reordering it because multiplication is commutative. But got to remember that that is 16 times the area squared. So if I divide both sides by 16, I get s times s minus a times s minus b times s minus c, and then I can take the square root of both sides, and oh my gosh, will you look at that. There is Heron's area formula. Okay? Whew. Now, let's go ahead, and now that you see that there actually is some justification for it, I'm so happy that you're happy. Let's go ahead and let's do a few problems. Okay? Now, we have side, side, side here. That's great. Okay? This right here is A. This right here is B. This right here is C. My semi-perimeter is 28 plus 35 plus 17, which, by the way, is 80, and that winds up being 40. So my semi-perimeter is 40. So my area is equal to the square root of 40. 40 minus A, which is 12. 40 minus B, which is 5. And then 40 minus C, which is 23. And then we break out our handy-dandy calculator. That's going to be nice and helpful. We get the square root of 40 times 12 times 5 times 23, and our area is approximately 234.947 units squared. Okay? And that should be, relatively straightforward. And here's the thing. Could we do it another way? Yeah, of course. We know the law of cosines. We can use the law of cosines to find any one of those. Actually, let's go ahead and do that. Let's use the law of cosines to find angle B. Okay? Now, that means that I have b squared is equal to a squared plus c squared minus 2ab times cosine of b. So cosine of b is going to be 35 squared minus 28 squared minus 17 squared, all that over negative 2 times 28 times 17. Okay, well, let's go ahead and find that ratio, okay? Okay, let's put that ratio in. 35 squared minus 28 squared minus 17 squared. Let me double check, make sure I'm getting this correct. Okay, don't want any keystroke errors in there. Negative 2 times 28 times 17, and my ratio is negative 19 over 119. That's ugly. And then we're going to take the cosine of that, and we get our b value at approximately 99.187 degrees. Now, if that's my b value, let's go ahead and store that in so that we have it in there. And I know that my area by the other formula should be, if we're using b right here, it should be these two sides, and it should be 1/2 AC sine b, which in this case is 1/2 28 17, and then sine of 99.187. Well, let's go ahead and do that. We have 0.5 times 28 times 17, okay, times sine of that value right there, and we wind up getting, oh my gosh, will you look at that, 234.947 units squared. Same answer. Okay, either way. Now, I would rather do it by Heron's area formula, okay? But you could do it the other way. It just winds up being a little more work. Well, here's the thing. You don't have to prove it. You just have to use it, okay? Let's go ahead and look at this last one right here before we call an end to this video. I have A, B, and C. Take a first look at it. There doesn't seem to be any problems with it. It's not like C is 3 and therefore, A and C aren't as long as B or anything like that. It looks like it's going to make a full triangle. So let's go ahead and say the semi-perimeter is going to be 5 plus 9 plus 7. Well, unfortunately, that's going to be a fraction. So we have 5 plus 9 is 14, plus 7 is going to be 21. 21 over 2. So 21 halves. It's probably, I hate to say this, probably easier just to leave it as 10.5, especially since you're going to be plugging it into your calculator anyway. And the thing is that decimals are great for your calculator. My bias against decimals is the fact that students, it's been my experience in my career that students don't realize that once they put their calculator down, that fractions are so much easier to deal with. Fractions are so much easier to square. They're so much easier to do a whole lot of things with. And that's I kind of rail against decimals simply because except for your calculator, fractions wind up being so much easier. Okay, so we want area is equal to S, 10.5, S minus A, 5.5, S minus B, 1.5, and S minus C, 3.5. So if I'm going to take those values, take the square root of 10.5 times 5.5 times 1.5 times 3.5, and what I'm going to get is an area of approximately 17.412 units squared. I'm gonna pass on doing this one the other way as well. I think that's good for right now. I'm going to I'll go ahead and do another video on those two problems, the one from yesterday and the one from the day before that I passed on. And if I still have steam after that, I may do some supplemental videos as well. No, you're not going to be tested on them. Should you want to watch them anyway? Yes. And if you don't want to watch them because, quote unquote, they're not going to be on the quiz, why should I bother? Grr, okay? Don't be that guy. Don't be that girl. If you have any questions on this video or any of them, obviously, go ahead and shoot me a message on Teams or an email, and I will try to get back to you as soon as I can. Bye.